Today we are going to start 10.3, Properties of Chords. As you know, a chord is a segment in a circle with both endpoints on the circle. So by now we should be able to label a semicircle, diameter, chord, major arc, and minor arc. So pause your video, make sure you have those labeled. Remember, a semicircle measures 180 degrees, it's half the circle. A diameter has endpoints on the circle but also passes through the center of the circle. A major arc measures greater than 180 degrees, a minor arc measures less than 180 degrees, and a chord has endpoints on the circle. Our first theorem is theorem 10.3. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if AB is congruent to CD, then we can say arc AB is congruent to arc CD. So if segment AB is congruent to segment CD, then arc AB is congruent to arc CD. For the first example, circle P and circle Q are congruent. FG is congruent to JK, and the measure of arc JK is 80 degrees. So because the chords are congruent, we can say the arcs are also congruent. So the measure of arc FG is also 80 degrees. For number 2, we're going to use circle D. So they tell us that the measure of arc AB is 110 degrees, and they want us to find the measure of arc BC. We know that the chords are congruent. They both measure 9 units. So because the chords are congruent, the arcs are also congruent. So BC will also measure 110 degrees. So the measure of arc BC is also 110 degrees. For part B, they tell us that the measure of arc AC is 150 degrees, and they want us to find the measure of arc AB. Because chord AB and chord BC are congruent, they both measure 9 units. We know that arc AB and arc BC are also congruent. So before we can find just arc AB, we have to find the measure of arc ABC. We can do that by taking 360 and subtracting the measure of arc AC, which is 150. We get 210 degrees, so we know that arc ABC is 210. Because arc AB and BC are congruent, to find the measure of just arc AB, we can take 210 degrees and divide by 2. So we're going to get 105 degrees. So arc AB is 105. Arc BC is also 105. Bisecting arcs. If arc XY is congruent to arc YZ, then the point Y and any line, segment, or array that contains Y bisects arc XYZ. So we're taking a look at arc XYZ, and it's saying that Y and segment CY is a bisector of arc XYZ because arc XY and arc YZ are congruent. So it's just bisecting that bigger arc into 2 equal smaller arcs. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So here we have QS is a perpendicular bisector of TR, so we can say that QS is a diameter of the circle. So if segment QS is a perpendicular bisector of chord TR, then QS is a diameter. Theorem 10.5, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So here we have EG is the diameter of the circle. Because it is perpendicular to chord FD, it will bisect the chord, making segment FH congruent to segment HD, and it will also bisect the arc. It'll bisect arc FED, making arc FE congruent to arc ED. So for example 3, we're going to use the diagram of circle E to find the length of AC. So here, because our diameter is perpendicular to our chord, we know two things. We know that the diameter bisects the chord, making segment CF congruent to segment FA. It also bisects the arc, making arc CB congruent to arc AB. Because segment AF is 7, we know that segment FC is also 7. So to find the measure of the entire chord AC, we're going to do 7 plus 7, which is 14. So AC equals 7 plus 7, which is 14 units. For 4, we're going to find the measures of all the indicated arcs. So because our diameter AD is perpendicular to our chord CE, we know two things. We know that it bisects the chord, making segment CA congruent to segment AE. We also know it bisects the arc, making arc CD congruent to arc DE. So first we have to solve for x here. We're going to set those expressions equal to one another because we know those arcs are congruent. So we have 9x equals 80 minus x. We're going to solve for x. We're going to add x to both sides. So we get 10x equals 80. Then we're going to divide by 10. So we know that x equals 8. Now we're going to plug in 8 for x to find some of our arc measures. If we take a look at arc CD, we have 9 times 8, which is 72 degrees. Here we have 80 minus 8, which is also 72 degrees. We should get the same value because those arcs are congruent. Now to find the measures of our other arcs, if we take a look at our semicircle here, we know that these two arcs together have to add up to 180. So if we do 180 minus 72, we know that arc CB is 108 degrees. And same thing on the other side. We know that these two arcs, arc BE and ED, form a semicircle. So again, 180 minus 72 will give us 108 degrees. Now that we have the measures of all of our missing arcs, we can find the measures of these indicated arcs very easily. So I want you to pause the video and find the measures of these indicated arcs A through E. So CD, we have 72 degrees. DE, we also have 72 degrees. CE, we have 72 times 2, which is 144 degrees. CB, we have 108 degrees, and CBE, we have 108 times 2, which is 216 degrees. All right, our last theorem, we have theorem 10.6. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So equidistant means equal distance. So if segment FE is congruent to segment EG, that means that chord AB and chord CD are the same distance away from the center of the circle. We can say that chord CD is congruent to chord AB. So if segment FE is congruent to segment EG, then chord AB is congruent to chord CD. So in the diagram here, we know that QR is congruent to ST, and they both measure 16. So we know our chords are congruent, which tells us that they are equidistant from the center of the circle. So we know that segment CU and segment CV are congruent. We can set those expressions equal to one another. 2x equals 5x minus 9. We're going to solve for x, subtract 5x from both sides. We get negative 3x equals negative 9. We're going to divide by negative 3, so we get x equals 3. They want us to find the length of CU. We know CU is equal to 2 times x, which would be 2 times 3. So the length of CU is 6. Last example, we know ST equals 32. And we know that CU and CV are congruent, and they both measure 12. So they want us to find QR. So because chord QR and chord ST are equidistant from the center of the circle, they're both 12 units away, we can say that the measure of QR is also 32, because those chords are congruent. Because the segment CU is perpendicular to the chord, we can say that it bisects the chord, cutting it in half, which means segment QU and segment UR are congruent segments. So to find the measure of each, we can take 32 and divide by 2. So we get 16, so QU and UR are both 16 units. Lastly, we want to find the radius of C. So whenever they ask us to find the radius of a triangle, we're actually going to have to use the Pythagorean theorem and form our own right triangle. So I'm going to draw a radius of the circle, and I'm going to form a right triangle. So from the center of the circle, I'm going to draw my radius out to point R. So now I've formed a right angle by drawing my radius. I'm going to draw this triangle out separately so it's easier to see. So we have the center C, we have point U, here's our right angle, and we have R. So we're trying to find segment CR, that's our radius. So I'm going to label that one X. We know that CU is 12 units, and we know that UR is 16 units. So now we can use the Pythagorean theorem to solve for our radius. So we have 12 squared plus 16 squared equals x squared. The radius will always be our hypotenuse, always the C term. So we have 144 plus 256 equals x squared. 144 plus 256 is 400. We're going to take the square root of both sides. So we get x is equal to 20. So our radius is 20 units.